Okay, so the climate models produce rainfall. We have to bias correct that rainfall to make it look look a little bit more like reality. But that's only half the story. Uh, River flow is very different from rainfall. It, as rain falls on a surface, some of it goes into the ground, some of it flows off the surface, and that depends on a whole range of factors, which are due to the geology and the land cover and the topography. And for that, you need hydrological models. There's a whole range of hydrological models available to us. All are slightly different. Some are calibrated, some aren't calibrated, some have very good representations of evaporation, some don't have, some have good representations of the snow melt, some don't. So one thing we've been doing, and we've had a big intercomparison of all these hydrological models in a project called WaterMIP, where we've taken 13 different hydrological models which can be run all over the world and compared those outputs. And one important thing that we've been able to do is to be able to use the forcing data, the consistent gridded data for the whole world that we've produced, to run all these models with exactly the same forcing data, so that it is a genuine comparison of the way the models are running. And that's been very instructive. When we first started this, there was a very, very big range of the outputs, which the outputs of these models are river flows, and there was a very big range of the flows that were coming out of these models. The evaporation was very different, the speed of runoff was very different. So that has both given us a much better handle on the uncertainty of our predictions of river flow, but has also provided a big incentive for the model developers to go away and improve those models. And we are already seeing the results of that in what we believe are improved hydrological models for this purpose.
And this is a novel approach to this forcing data and apply it to these hydrological.
Yes, I think it's not so much more novel, but it's never been done before in these sort of with these sort of set of models, and it's never been possible to do it because we haven't had these consistent data sets which can drive all the models. So it's been a very important development, which is a combination of a huge amount of work producing the forcing data, and it's just been an opportunity which we felt should be done, but just wasn't possible until fairly recently.
And that data is now available for anyone with a model to
yes, run, yes. I mean, we expect this both the forcing data and the model output to be available to publicly available to anybody who needs it, and it'll be going onto a web-based interface where anybody can download it anywhere in the world. And one very useful thing is you can use it globally, so you can look at the runoff from big continental areas, but it will also be possible to download small components of it. If you're just interested in one region and want to get what we consider is the best data for driving hydrological models for a region, you'll be able to download that, and as I say, it'll be free, and we'll try and make it as easy as possible.